All right, let's take a look at the concepts of the applications of quadratic functions. So let's look at applications of quadratic functions, if you will. So applications of quadratic functions. So we know about these quadratic functions in terms of them being parabolas, right? And parabolas either open up or down. Okay. So, well, that has implications then, right? We talked about the range already with that last time, but let's look at the application of it, right? So let's look at the two cases again. Two cases. So in terms of those parabolas. So first case is when we have, let's say here's y, let's say here's x. Let's say we have a parabola that opens upward. All right. So in this case, again, we'll say f of x equal to ax squared plus bx plus c, all right, where there's the vertex right here, right? That's the vertex, all right? We talked about that last time. And so then what's the meaning of the a? Well, the a is going to be positive, right? What it says parabola opens up. This number a in front of x squared, the coefficient of x squared is what? Positive. Now, what about this case here? Well, if a parabola opens up, you recall the range is going to be from this low point to infinity, right? And so this parabola, in other words, has a minimum function value at the vertex. Okay, so this case here has a minimum function value, but no maximum because it opens up. It goes on forever in terms of its function values. So it has a minimum function value. And that minimum function value is, again, the y-coordinate of the vertex. So again, this is the y-coordinate of vertex. All right? So, and I'll call that y sub v, meaning y-coordinate of the vertex. All right? Now, let's look at the other case. The other case was when the parabola opens what? Opens downward. So let me draw a sketch down here. So let's say here's x. So let's say parabola opens downward. Sorry about that. Kind of hard to draw on the sketch pad. All right. I kind of messed up there. Sorry about that. Let me try it again. Right, so, but my point here. Sorry about the mess here with the sketch pad. But again, let me just quickly draw this. There we go. Parabola opens downward. Again, there's the vertex. All right. But for a parabola that opens downwards, you can see since it goes down forever, right? There's no minimum, but there's a what? There's a maximum value. So this one has a maximum value. There's a max function value. So if it opens up, it has a minimum, but not a maximum. If it opens down, there's a maximum, but no minimum, because it goes down forever, right? So it covers all the values, all the y values below this y coordinate of the vertex. So again, the max function value, once again, is the same thing. It's the y coordinate of the vertex. So in both cases, you're finding the y coordinate of the vertex. So if I were to give you a quadratic function and ask you to find either the minimum or the maximum, then we can certainly do that here. All right, but let's talk about this this minimum or maximum here, right? So to find the y-coordinate of the vertex, though, I need to know what is the x-coordinate of the vertex first. Well, just like last time, we had the formula, right, where x sub v is what? Negative b over 2a. All right, so this is the x-coordinate of the vertex. So just plug in this number to get the y-coordinate of the vertex, or the minimum or the maximum, depending on which one you're dealing with, right? In other words, the y-coordinate, again, if you recall, is going to be f of x sub v, all right, or f of what? Negative b over 2a, that formula we had earlier, all right? So let's go ahead and try that. Let me go and clear up the screen. All right, so let's give you a function here, quadratic function. Let's start with simple. How about f of x equal to, for example, let's say x squared minus 3x plus 2, for example. All right. So here's a standard quadratic function, and in this case, this is a parabola that opens up or down. Well, since a is equal to 1 here, right, which is positive, right, this opens up. parabola opens upward. That means what? We have what? We don't have a maximum because it opens up, but we do have minimum. So I'll say find minimum. So let's find the minimum value. Find min value, or the minimum function value, right? But again, that's just finding what? The y-coordinate of the vertex for this quadratic function, right? So again, let's use that formula. So x sub b is equal to what? Negative b over 2a, all right? So just plug it in, right? So that's equal to what? Well, my a is 1. What's my b? There's my b, right? My b is right here, negative 3. So negative 3 for b over 2 times 1. Or if you will, positive 3 over 2, positive 3 halves. This is the x-coordinate of the vertex. Again, that's not the answer. The minimum value is the y-coordinate of the vertex. So minimum function value, min value is going to be what? Plugging in the 3 halves into this function. So that's going to be f of positive 3 halves. F of positive 3 halves. All right, so let's just plug it in. And again, you can do it by calculator or just show the work. Here, I'll show the work. That's going to be 3 halves squared, all right, minus 3 times 3 halves plus 2. At this point, you should probably punch in the calculator, but I'll show some more work. 9/4, right, 3 halves squared minus 9 halves plus 2, all right. If you want to see some more work, then so there it is, 9/4, and that's 4 is the common denominator. So I'll rewrite 9 halves as what? 18 over 4. You times by 2 over 2 here, right? And what about 2 here? Well, that's 8 over 4. That's all. That's going to be 2, right? 4 is the common denominator. So that's going to be what? 9 minus 18 is negative 9. Plus 8 is going to be what? Negative 1. So negative 1/4 is the minimum function value, or the minimum value of this quadratic function. So negative 1/4 is what we're looking for here. All right. So for the minimum value. Right? So no big deal here. You just find the y-coordinate of the vertex here. So pretty short section, pretty short material here, if you will. Let's try another one. Let me go and clear out the screen. Try this one here. What about g of x equal to, let's say, negative 2x squared plus 8x plus 7, for example, right? Now so my a is what? Negative 2. So that means what? That means parabola opens what? Opens downward. So we have a downward opening parabola. That means what? There's no minimum because it goes down forever, but there's a maximum. So I'll say find a maximum. So find max function value, or max value, if you will. All right. So again, that's just the y-coordinate of the vertex is really the bottom line here. So there's my b here, right? Positive 8. So therefore, the x-coordinate of the vertex. Again, just write the formula down again. Negative b over 2a. That's going to be negative 8 over 2 times negative 2. That's going to be what? Negative 8 over negative 4, or positive 2, since the negatives divide out. Alright, so that's the x-coordinate again of the vertex, but again, we need to find the y-coordinate of the vertex by plugging in the 2. So the maximum function value here is going to be what? F of 2, if you will. Alright, let's plug it in. So negative 2 times 2 squared, right, plus 8 times 2 plus 7. That's going to be negative 2 times 4, right, 2 squared, plus 16 plus 7. That's going to be negative 8 plus 23, 16 and 7. So what? Positive 15 is the maximum function value that this quadratic function takes on. Right? So that's the max value. So again, all we're doing is what? To find the minimum or the maximum, depending on what a is. Right? If a is negative, then we're finding the maximum. If a is positive, we're finding the minimum. Right? Then all we're doing is what? First find the x-coordinate of the vertex, as we've done previously, using this formula, and then to find a maximum or a minimum value, simply plug it into the function. I should say this is g, not f, since my function is g now, right? Sorry about that. But simply plug it into the quadratic function to get the y value, which is going to be the max value or the minimum value, depending on the application, depending on what type of quadratic function we're dealing with. All right, so let's finish off. So no big deal. They're pretty short material here. Let's focus on some application problems. Let me go and clear out the screen and give you an application problem to solve here. Let's go and clear this out. All right, so let's go ahead and take a look at this problem here. All right, so let me go ahead and get it in focus here. All right, so let's take a look at that here. All right, so let's take a look at this application problem. So an event in the Summer Olympics is the 10-meter springboard diving event. So in this event, the height S in meters of a diver above the water t seconds after jumping is given by this quadratic function. In case you can't see this clearly, let me go write it out. So you're given that S of t, which is the height of the diver above the water after t seconds after jumping, or t is the time, S is the height, right, again, is negative 4.9 t squared plus 7.8 t plus 10, in case you can't see this little function clearly here in the video. All right, anyways, what is the maximum height that the diver will be above the water? Round to the nearest tenth. Well, so no big deal again. Maximum height, again, max keys maximum, right? So that means what? We're finding the y coordinate of the vertex, once again, max height, height being s, right? So again, first find the x coordinate. In other words, find t, find the time when the diver will be at that max height. So t is going to be what again? Negative b over 2a. Okay, so what's my a here? Well, my a is what? Negative 4.9. 4.9 there, sorry about that. And my b is what? 7.8. Alright? So that's going to be what? Negative 7.8 over 2 times negative 4.9. Alright? So that'll give me negative 7.8 over negative 9.8. Right? That divides out here. So let me punch that into the calculator. So t is going to be roughly, let me go and punch on the calculator. So punching this into the calculator, 7.8 divided by 9.9, I get roughly, go roughly here, 0.796. I'll just round to 3 decimal places, if you will. So I plug it back in to get the maximum height once again. So S of 0.79, so roughly 0.8 seconds into the jump, that's when the diver is going to be at the maximum height above the water. So S of 0.796, plugging that in for t, you're going to get negative 4.9 times 0.796, or 0.8 if you want to use that, squared, plus 7.8 times 0.796 plus 10, punching out the calculator and rounding it to the nearest tenth here, right, I get approximately 13.1 meters above the water is the maximum height of the diver based on this quadratic function right here. All right. So again, all we'll do is what? Just finding the y coordinate of the vertex if we want to find the maximum height. Let's try another one. Let me go and clear out the screen right here. Well, let's take a look at this one right here. So let's try this problem right here. Alright, let's take a look at this application problem. So a manufacturer of ovens believes that the revenue R in dollars the company receives is related to the price P in dollars of an oven by this function. Again, let me write this function out in case you can't quite see it. R is revenue, P is the price of the oven, right? R of P equal to what? 125P, alright, minus 0.25 P squared, alright? What price will give the maximum revenue? But look at the question again. What price will give the maximum revenue? So in this case, we're not being asked for the maximum revenue. We're not being asked for R. We're being asked for what? For P this time, right? So this problem is even easier because we're just finding what? The x coordinate of the vertex. We don't have to plug it back in to find the y coordinate because it's not asking for the maximum revenue. It's asking for the price. Can we see that? So therefore, all we have to do is use that negative b over 2a formula, and that's good enough to get the answer. All right. So there's no need to plug it back in because we're not being asked for the maximum revenue. Now, if we are being asked for that, we can certainly plug it back in. But the answer here is even easier. Simply say that the price that will give the max revenue is going to be negative b over 2a. Once again, all right, no big deal. But look at a and b carefully. This is p, and this is p squared. So remember, a is the coefficient of the square term. So my a is going to be what? Negative 0.25 here. So be careful on a. My b is going to be what? The 125. Okay, so make sure we correctly identify a and b because the function is written a little bit differently, right? But again, the key is what? A has to be the coefficient of the square term. B is the coefficient of the p term in this case. All right. So again, let's plug these numbers in and punch in the calculator. So that's going to yield what? That'll give me see negative b. So negative 125, right, over 2a, 2 times negative 0.25. And that's going to be negative 125 over negative 0.5. If I punch it in, calculator, I'm going to get, punch in the calculator, I get the price to be what? $250 is the price I should charge for the ovens if I want to get the maximum revenue out of it. Again, all we're looking for is this 250 price, just the x-coordinate of the vertex. We're not even going to find the y-coordinate of the vertex for this particular problem. So read the question carefully and see what's being asked. Is it the x-coordinate? In this case, that is the case. Or the y-coordinate in the diving problem we did earlier. All right, so no big deal. Again, all we're doing is what? Focusing in on the vertex, but that's basically it. All right, let me give you a couple problems to find the max and min here and post into Blackboard. Just go and clear out the screen. I'll just do a couple of problems here. So here it is. Let's take a look. Let's take a look at this function here. So f of x equal to, let's say, negative 3x squared plus 4x minus 1. Let's go ahead and find in this case, find what this parabola opens. What opens downward, since that the coefficient of x squared is negative, right? It has a max but not a minimum. So in this case, find the maximum. Find max function value, or find max value. All right. Number 2, say g of x equal to, let's say, 4x squared plus x minus 5. All right. In this case, this parabola opens upward since the coefficient of x squared is positive. So there's no maximum, but there's a minimum. So I'll just say find minimum value. In this case, but in both cases, you're finding what? The y-coordinate of the vertex. Of course, you got to find the x-coordinate first to get that. All right, so find minimum function value. All right, so no big deal. Apply the concepts here to post the solutions into Blackboard and post it as a fraction, if you will. So use the slash key for the fraction here. All right. So anyways, that's all we have for right now. Then until next time.